All right, continuing with 2.9, this would be part two. So, not every function that contains a quotient requires a use of the quotient rule. And again, sometimes you guys get excited, right? You just learned a new technique. So, therefore, you want to start applying to everything that pretty much looks kind of the same. So, that's pretty much what this exercise would do here. So, in this case, always the first thing that you guys want to be thinking about is that can I simplify this where I won't have to be able to use so many extra rules? And if you notice here, pretty much you can simplify this, right? We have y equals x squared plus 3x. We want to rewrite it everything as a single leg. Separate the fractions. So we're looking at y equals x squared over 6, and then plus 3 over 6 times x, right? Actually, let me rewrite this as 1 over 6 in front of it. It's going to make things a lot easier. So now we can find y prime, right? The constant here is 1 over 6, so that remains. And then the derivative of x squared is 2x, so times 2x. And then the derivative of x is 1. And then 3 over 6, you can always simplify that, right? We'll do that the next step. So our last simplification would be y prime is equal to, that would be 1/3 times x plus 1/2. All right. So let's look at example B now. So same thing. So we want to be careful here, right? First, we want to distribute, right, on top everything. So let's do that first in the rewrite part. So this would be equal to negative 9x plus 6x squared, and then everything over 7x. And now again, split it up, right? So that would be negative 9x over 7x plus 6x squared over 7x. Right? This goes away, and then we can now pretty much differentiate to find y prime. So y prime, derivative of a constant, negative 9 over 7 is 0. And then one of these goes away. So the derivative of x is just positive 1. So my y prime would be 6 over 7. And then my final simplification would be pretty much the same thing. And again, a different way, same as before, right? Like they like to ask, especially in the FRQs, they like to give you guys tables. It could be just one part of it, just to make sure that you guys can apply the simple concept of the quotient rule, right? So again, this still applies here. Like we're still going to be using the low D high minus high D low over low low. All right, so we have a table. So the values of the two differential functions, f of x and g of x, along with the derivatives, are given in the table below for several values of x. So again, we have points, and then we have the slopes at each of these points. It says given h of x is equal to f over g of x, find h prime at 2. So we're looking for h prime of 2. So first let's find h prime of x. Again, this is your high function, this is your low function. So we're looking at low d high, right? So low d high minus high d low all over the low low. So in this case, this is going to be f, so g of x, g of x times f prime of x, and then minus high d low, so that would be f of x times g prime of x, and then everything over g of x, quantity squared. And then here, pretty much, you just have to substitute if you want to figure out what's h prime of 2, right? So h prime at 2 is equal to g of 2 times f prime at 2 minus f of 2 times g prime at 2, and then everything over g of 2 quantity squared. So we still start looking for those values, so and then do the substitution. So g of 2 is, let's look at our table right there. G of 2 is positive 3. So that would be positive 3. F prime of 2 would be negative 1. F of 2 is equal to positive 4. So minus 4. G prime at 2 is 3 over 2. So 3 halves. And then everything divided by G over 2, which is positive 3 quantity squared. And again, one more time, we simplify. So we're going to get negative 3, negative 4 times 3 halves. That's just going to be negative 6 all over 9. So this is negative 9 over positive 9 equals to negative 1. So we can say H prime of 2 equals negative 1. And then for the following problem, so they're giving us a different function, right? We're still using g of x, but now they're giving us the square root of x. So we still want to set it up. So we're looking for low, high, right? And then d low, and then d high. So make sure you guys are consistent with your setup. That way for sure you can remember it every time you're trying to set it up. So again, if I look here, I have a rational function. So this is going to be the square root of x for the low function, g of x for the high function. D low, that would be this, remember, this would be x to the 1/2. If you find the derivative of that, you're going to get a 1 over 2 square root of x. And then the derivative of g of x would be just g prime of x. So let's find g prime at 4 now. So looking at g prime at 4, so that's equal to low d high. So low is the square root of 4 times g prime at 4. And then minus g of 4 times 1 over 2 times the square root of 4. And then everything divided by low, which in this case would be just the square root of 4 quantity squared. And again, now we want to substitute. So let's see what the values of g prime of 4 are and g of 4. So g of 4 is equal to positive 5, and g prime at 4 is equal to positive 1. So let's substitute those in. So we're going to get square root of 4 is just positive 2 times g prime at 4 is positive 1. And then minus g of 4, which is 5. And then times 1 over 2 times the square root of 4 would be 1 over 2 times 2, which is 1/4. And then everything divided by positive 4. And these two go away. So from here, just want to simplify. So that's going to give us 2 minus 5 over 4. Everything divided by 4. Again, this is the same as 8 over 4, right? So that's 3 over 4 divided by 4, which in this case would be just 3 over 16. So we can come to the conclusion that g prime at positive 4 equals 3 over 16. So that would be my slope at 4.